Hello and welcome to another webinar from Robinson's Facility Services. My name is Kevin Ayres. I'll be your host for today. If you haven't already seen all our other webinars, we've got loads now. Make sure you go on the website and check those out. We'll be talking about those a little bit later. But the main thing we're focusing on today is lightning protection. And the amount of pun potential with lightning protection is enormous. I will try and hold myself back. Starting with, obviously at Robinson's Facility Services, we have a whole range of experts on a really wide variety of topics. And the person we had lined up was struck by lightning. No, kidding. The person we had lined up sadly couldn't make it. And Lewis Nola has stepped into the breach. So be kind with him because he hasn't had a huge amount of time to prepare. But we have lined him up and he is ready here to take us through all about lightning protection and compliance. So Lewis, welcome to the show. How are you doing?
Yeah, not so bad. Yourself?
Yeah, really good. Apart from the fact it is absolutely hammering it down with rain, proper Yorkshire style weather. I don't live in Yorkshire, but it's proper Yorkshire style weather here. What's it like where you are?
Yeah, pretty much the same. Yeah, down in Cardiff. So yeah, it's always wet here.
Yeah, well, it's always wet, but I live on a hillside on a farm. I'm not a farmer, but I live on a farmhouse, and basically the rain I can see is like going that way, not down that way. So I guess leading into talking about lightning protection is these sort of wild, wet and windy days when, lightning can strike, right? So I'm looking forward to getting into this. But before we get into this, like, how does one get into being a lightning expert? Like, how did you get to this point, Lewis?
It was an accident. I was working in a bar actually as a bar manager, and my mum saw an advert and thought it was for lighting protection. So she thought I was actually going to be an electrician. And then when I went to the interview, I found out that it wasn't that at all. Something completely different. And yeah, it's been quite a long journey to get to this point, but yeah, it's been very interesting. Lots of different projects, lots of different situations, industries. It spreads far and wide, shall we say.
Well, you've seen a lot of tall buildings, I imagine, in that time.
You'd be surprised. There's not that many tall buildings. So most tall buildings get struck, but it depends on the build-up of ions in the area. There's been cases where footings of buildings have been struck.
Oh, wow. Okay. Interesting.
Yeah.
Well, there you go. I've learned something already. So I guess that's really important. So people might think then, oh, this isn't relevant to me. I don't have a tall building, but you've already shown us that isn't necessarily the case. People need to be aware of this, whatever kind of facilities they're managing, by the sounds of it.
Yep.
Great. Well, look, why don't we get into the questions? Lewis, what is lightning protection and why is it relevant? I guess we've just talked there. Why is it relevant to commercial property owners?
So yeah, it's a system designed to intercept a lightning strike. It's not there to attract a lightning strike. It's there to basically prevent the building from any damage caused by a direct strike to a building, or subsequently it's there to protect the building from subsequent effects of lightning protection as well. So there's two parts to it in theory. You've got the lightning protection, which covers the structural element, but then you've also got the surge protection, which covers all the internal protection as well. So any residual effects of lightning. It's relevant to all property in theory because everybody has a duty of care to others. Everybody has a duty of care to people that live in these structures. Therefore, it's a way of safeguarding a building from damage, and also dangerous sparking. So therefore, it's more of a reduction of fire risk.
So with the things like the surge protection, and we'll get into this, but do you mean that there are other benefits other than just if you've got the surge protection in? Are there other benefits other than just the lightning strikes?
Sorry, repeat the question.
Sorry, from the way you said it, that it implied that I'm no expert at this, so I'm just asking the questions perhaps our audience wants to know. did you mean that there are other benefits? There are other ways that you could get, say, a surge than just lightning strike, and therefore, if people have this in place, it's not just lightning strikes; it actually protects from other things. Or did I misunderstand?
So yeah, there's more surge events that happen on the grid now because the grid is now quite at capacity. So there's lots of switching surges, lots of power cuts that can cause spikes to the point that even some roadworks can cause spikes as well. So say for instance, somebody's working down the road, they go through a cable, that will send a spike down as well. It's not of a magnitude or of an energy in regards to lightning, which we'll see a little bit later on, but it's still a potential of causing minor damage to circuitry, to equipment within a building, servers, for instance.
Right. So that's interesting. So from what you're saying, if the network is now, the grid is now at capacity, the sort of surge events are happening more often. And also, I'm assuming that with all the stuff about climate change and so on, I'm assuming that are storms happening a little bit more frequently in the UK, and therefore more lightning strike events.
Yeah, so we use a map by environmental technologies, EA technology, sorry. The maximum at the moment is around about 14 days worth of lightning. They've been tracking, that's based on a map from 2014. It's likely to increase over the next 5 years by another 50%.
Wow, right.
So we're looking at upwards of 21 days worth of lightning. The closer you get to the equator, the more frequent the storms are. So I've had lots of discussions with people from South Africa, for instance, where at certain times, so 6 months out of the year, they've said that you can set your watch to when the lightning comes on and when it goes off.
Wow, right.
Yeah.
So in terms of our perception of, how often lightning happens, what you're saying is that there's a good chance that over the next 5 years, that's going to go up. And obviously, this sort of protection and the systems we might need to be put in place, we're at least thinking the next 5-10 years, right? So in terms of people's planning, they need to be planning for that increase, even though their perception might be, well, lightning strikes are this, actually, it's a good chance they're going to go up by about 50% over the next 5 years.
That's correct. Again, not all structures need lightning protection. Obviously, a risk assessment will determine that. That will go through a complex set of calculations to determine whether lightning protection is required. If lightning protection is required, then surge protection is required as well.
Right.
If lightning protection is not required, then surge protection is highly recommended based on not only lightning, but also all of these surge events that happen.
Yeah, especially as we all have computers and people are using more and more high tech equipment, which is very sensitive, as you say. So we're all very. Dan says I've got you're making me worried now. I've got about an 8 terabyte drive of all of our photos, and so thankfully they're all backed up now. Actually, but yeah, it's highly dependent on the quality of electricity, and which is not great here rurally. So perhaps I need to. We'll have a chat afterwards, right? See if there's anything I can do. But in terms of facilities management, then, so you sort of implied there about a risk assessment. So what are the legal and regulatory obligations around lightning protection?
So in theory, lightning protection is not a legal requirement. It's key to note that it's not a legal requirement. However, that being said, as previously mentioned, under the Health and Safety at Work Act, you have a duty of care to people. For instance, people that are working in buildings, for instance, you've got a duty of care to your employees. You've got a duty of care to people that you say, for instance, rent spaces out to people. So therefore, the drive is through the Health and Safety at Work Act, as well as coming through from the insurance companies as well. Lots of insurance companies tend to say you do need it, or they'll say, please go and ask a specialist to undertake a risk assessment. There are other there are other sites, for instance, that are actually a mandatory requirement, but it's not governed under our standard of 62305. It's governed under, say, for instance, DESIR regulations, COMA regulations. These sites with explosive atmospheres, with solid explosives, they are a mandatory requirement. They are required because there is a bigger consequence of damage and impact.
I would imagine, though, from my experience in industry way back, when I was learning about, I used to work for ESSO, as we learned a little bit about explosions and things. Obviously, they're highly pretty much everything at ESSO makes it pretty highly flammable, obviously. So I remember we were learning about things like grain silos. So, there might be other things that you wouldn't think were inflammatory, but might need, I would imagine they would need anything like you've got flour or dust that's flammable.
So if you look at it from a DESIR perspective, you've got zones 0, 1, and 2 that relate to gases, and you've then got zones 20, 21, and 22. 0 and 20 are basically constantly present. So there's either a dust on the 20 series or on the 0 to 1, 2 series. That's a gas.
Right.
1 is anywhere between 10 hours and 1,000 hours or more. And then zone 2, there's only a gas or a dust present for up to 10 hours a year.
Right.
So if, for instance, a grain silo, a flour silo was to get struck, the force that it can generate when it blows is basically like a shock wave, for instance. So under there's other standards. So this one would be 1127. It does say that you need to protect against 13 sources of ignition, of which 4 of them are related to lightning. So one is actually lightning. 1 is mechanical sparking. 1 is hotspots, and 1 is stray electrical currents. So we need to either mitigate or reduce that factor down so that it's a safe environment.
Sure. So when you say about mitigation, so who is actually responsible for installation, testing, maintaining these kind of systems?
So the facilities management team or the property owner is required to keep a record. However, they're also to ask a specialist to help them along the way. So the installation needs to be undertaken by a specialist and qualified as well, either to an MVQ level 2 or better still, an MVQ level 3. And that's in lightning protection, access and rigging. So therefore, when we done the MVQ, it allowed us to do rigging for film sets as well.
Oh, wow.
Yeah.
Very cool. Have you done any films I might have heard of?
I have Frankenstein.
Oh, okay. That seems a positive advantage to be hit by lightning. In front, you need lightning, surely. That's hilarious.
Yeah, that was done at Longcross Studios. I didn't know what the name of the film was until I got there, and they said this is Frankenstein's castle, and I thought, oh, this is something that definitely needs lightning protection.
Yeah. But from inside, right? That's hilarious. That's how you going to animate Frankenstein without lightning, right? Brilliant. That's quite funny. So guys, if you're watching, lots of people watching online, so thank you so much for joining us. If you haven't been on one of these before, we really like some questions. So there is a chat function. So if you would like to ask Lewis a question, feel free. If you just want to watch, that's absolutely fine. We might deal with 1 or 2 as we go, and if not, we will pick up your questions at the end. So Lewis, it would be quite. I know you sent over some pictures which showed good practice, bad practice, and also a little bit about surge protection. So, would you like us to talk us through those?
Yes, sure.
Cool. So now it was funny because I was looking through these and I was like, the way you labeled them, I'm like, they were good and bad. And then I'm like, to me, to the untrained eye, it almost looked like the other way around. So are we looking, so forgive me, are we looking at good installation or bad installation here?
So the one on the left shows the use of a appropriate clamping product using a fixing point that is not damaging the flue for this instance.
Right.
The installer has found a suitable connection point, has used an appropriate clamp, and has used the correct size of conductor. The picture on the right hand side shows that again they've used a rod, a specific clamp which goes from conductor to rod, so it is fit for purpose. And also it shows that he's used a oxy inhibitor paste as well to make the connection a better connection and make it last a little bit longer and stop the oxidization effect between the rod and the actual copper.
Is that the little, you see the sort of little brown thing between the screw and the pin? Is that what you mean?
No, that's the copper. You can see sort of like a black gooey stuff. That's the oxy inhibitor.
Under the it's sort of between that plate and the pin, or sort of.
Yes.
Yeah. Oh, okay. Right. So it keeps that good connection. So rather than it sort of degrading over time and gradually that connection is sort of metal to metal, it makes a really nice sort of, yeah, I can see that. Great. Okay. So next couple here, what are we looking at here?
So, for instance, when you bond, so if there's not a suitable fixing point, so the photo on the left is if there's not a suitable fixing point on a round member, you are meant to use an appropriate clamp for which is called an RWP or a rainwater pipe connection, which has the conductor wrapped around tightly to the round member and then clamped appropriately so that it's nice and tight. It shouldn't be loose at all, and it shouldn't compress the pipe at all either. So it should maintain a solid connection. The photo on the right-hand side shows a down conductor that's been installed from roof level all the way down to ground level, maintaining safe distance the whole way through the installation away from the metal balconies to the right-hand side of the building.
Okay.
So therefore, we do not need to necessarily bond the balconies back to that system because we've maintained a safe distance away from the lightning protection system to avoid any flashovers.
Right.
So although I'm showing pictures of bonding connections, we don't necessarily need to bond every bit of plant. We don't need to necessarily bond any all metal work. There's other ways of protecting systems via air rods, via maintaining safe separation distances as well.
Wow, it's quite sounds quite involved. It's like really non-obvious. So what you were saying, I was trying to think, like, does that make sense to me? I was like, oh, I'm not quite sure, but we haven't got the time for you to teach me all this. But it sounds quite involved, like when you do, when you don't, and so on. So that's interesting in itself. And the last one here, in terms of good practice, what are we looking at here?
So again, this is another RWP connection. Although the satellite dish is not protruding above the roof level, it's still within a distance of which it could flash over between the lightning protection system and the antenna itself. So therefore, in this instance, we've opted to bond it, and then the coax cable that comes off of it, we then install the surge protection device as it entered into the building.
Okay, so what you're saying is that if now let me see if I get this straight. We don't need to know this specifically webinar, but I'm just interested. So because it's on the side, it's on the brickwork, it wouldn't necessarily get struck by lightning if it wasn't near the lightning rod. Is that what you're saying? But because it is near, there could be a jump to the lightning rod, and that jump would be hazardous. We might as well make a proper connection so there is no jump. Is that kind of?
Yeah, that's correct. So that there's no flashover, and so that everything's at the same potential, we connect the lightning protection system to the antenna.
Right. Yeah. Yeah. Okay. Now that makes sense. Yeah. Okay. In the same way as, if you get a spark, it's the spark that hurts, right? If it just flowed, it wouldn't. There's no sort of sudden build up and therefore a spark. Okay, so that's the good. We haven't got the ugly, but we got the bad. So talk us through this. Oh, I can see what's going wrong on the left, not so much on the right.
So the left, for instance, it's just laziness more than anything. You shouldn't have old. So this is called a bimetallic connector. So it connects aluminium to copper, so that there's no dissimilar metals, which also causes corrosion. We have to make sure that we get rid of the old stuff that we're replacing, and then fix appropriately the new stuff. So this is just laziness. It's not so much in regards to poor installation. It's just laziness as opposed to removing the redundant equipment.
Right. So it's not ready and yeah. Okay. And then what are we looking at on the right?
So the one on the right, this is showing you that somebody has tried to bond something, but has not used, bonded an air handling unit, but has not used an appropriate or sufficient clamp to do such.
I see. Yeah.
So if the separation distance can be maintained, we would look to install air termination rods to offer a protection. If the separation distance cannot be maintained, then we have to bond the equipment back to the system, but we must be using appropriate clamps. A screw through a conductor.
I was going to say a Phillips screw isn't going to cut it, but the sounds.
No, it's not. It's not been tested and it's not fit for purpose.
Yeah, no, I get that, and it won't have all the nice goo and the decent connection, and it's not big enough, and who knows what's going to happen to that in 3-4 years' time, right? And it'll just sit up there. It'll just sit up there, like so many things we've talked about. These sort of systems sit out of the way. You don't see them. They just sit there doing their thing, and or quietly rusting away. And you don't know you've got a problem until you've got a problem, and then you wish you got it sorted, right?
Yeah, I never noticed them until I started in the industry, and now everywhere I go, it catches my eye. Walking through Venice, walking through Paris, and then you can see them, and then you're looking at it, and then you're on a busman's holiday.
Yeah, I totally know what from a previous job. There was something I was working on, and you just see it everywhere, right? So it's you can't unsee it, right?
Yeah.
Okay, and what about these?
Again, down at ground level. So as you do your separation distance calculation, the length is the determining factor. If you undertake the calculation, the picture on the left and the picture on the right both do not require bonding.
Okay.
If in any doubt, you should always go and ask the specialist that's recommending these works, have you undertaken your separation distance calculation? These two images show unnecessary work, and they are not required. As long as there is a safe separation distance, as long as somebody has undertaken the separation distance calculation, neither one of these, the balcony nor the pipe, needed to be bonded.
So that's interesting. So you're saying it's not unsafe. It just isn't really going to do anything that was required, and it's unsightly. Like, we don't want these things on a, don't really want them on a building. We don't have to have them, right? And it's just more cost and maintenance and everything.
It's unnecessary costs. If you don't need to do it, it's just a waste of money.
Yeah. Cool. Right. So, I'll come back to surge protection. We'll have a look at that in a sec. So, just wanted to ask, with these systems, we talked about, like, do I need it or not, and therefore as well, I don't want things that I don't need, because it's more to maintain. So how often should I be maintaining my system? Once I've got something installed, how often does it need maintenance?
So under our standard BSN 62305, it does mention to test annually. That's only if it's deemed as critical, which is pretty much any occupied space. There are obviously some exceptions. Say, for instance, a pumping station in the middle of a field somewhere for a water company.
Right.
It's not regularly occupied. It's not deemed as overly critical unless it's a critical part of the water system that supplies local villages. It's recommended that then with the critical element that it's tested on a 12-monthly basis. However, we do recommend that we then test on 11 monthly so that we get a change in season. So we don't always get cold and wet. We might get dry.
Yeah. So gradually over time, you sort of tested it all year round.
Correct.
That's really clever. I would never have thought that. That's kind of interesting for all sorts of things. That's just as an idea. That's quite clever. I like that. And so I guess the reason for them being so regular is that, you know, again, a lot of these systems are at the edge, they're at the extreme, the elements, if they're on a tall building, you know, they're where things are windy, where things can work loose. And again, you don't necessarily think about that, but it's where, you know, you might have it, the more extremes, I guess, of our weather, you know, snow and all of these things, because they're out of sight, out of mind on the sort of the edges of your building, right?
Yeah. So again, like you said, you've got exposed metal, which is subject to extreme cold, extreme heat. There's expansion, there's retraction. Yeah. The joints tend to then potentially expand and contract, and then that causes degradation over time.
Yeah, no, makes a lot of sense.
It also is key to note as well is that if you're in a salty sea salt environment, the salt in the air, depending on the system that you've got installed. So say, for instance, if you're right on the coast, you shouldn't, in theory, have an aluminium system because the aluminium and the salt corrodes a lot quicker.
Right.
So it's recommended that you either use a stainless steel or you use a copper system in those environments because it's a little bit more robust. It deals with it a little bit better.
And are they more expensive though, or is there a reason why you'd go for one of that or other than the coastal aspect?
It is more expensive, but if you think about it from an installation perspective and a longevity perspective, if you put in a cheaper aluminium system and you're right by the coast, and then you have to then replace it, the extra money that it would have cost to put in a copper system.
Yeah.
No,
I was just kind of wondering whether, so normally by default you'd probably pick aluminium, but by the sea you have to do something else, which is true of a lot of, you know, marine grade is a thing, right? You know, it's marine grade for a reason because, you know, it gets a lot more bashing and a lot more that salt water and, you know, in all sorts of systems, right? So yeah, no, that makes sense. So before we go back and look at the surge protection, what are the risks of not having a lightning system? Like, you know, how risky is this, or, you know, what could happen?
In actual fact, it's very unlikely, but it still has a potential of causing damage. By not having a lightning protection system and then having, for instance, a risk assessment that says actually it's above what we call the tolerable risk. So there's tolerable risks associated with lightning protection, which deem that whether you do or you do not need it. If you don't have lightning protection system and say, for instance, that you haven't stated that to your insurance company, the insurance company are unlikely to pay out on any claim. However, that being said, sometimes insurance companies have been known to allow you to have a one shot. They'll pay it out, but then to get the premium and the cover for next year, you are to install lightning protection.
Yeah.
So
probably not something it's not really a risk you want to have, right? I assume you don't want to risk that they're going to Well, they might pay out, they might not. If once my building's burnt down. So
there's also the moral and ethical. Because if you're, as I said, you've got a duty of care to others, and if, for instance, you opt not to do that just to save yourself a little bit of money, then you could find yourself in court as well because you haven't done what you've been told that you've been asked to do.
Well, and you've got to live with that, right, as well. Quite aside from the legal aspect, you will live with that for the rest of your life potentially if it's been some major consequence. It's a big deal. No, that's really helpful. And it sounds like there's a common sense approach here. It's not like, if I get somebody in, they're always going to recommend, get lightning protection. It's like, no, there's a risk assessment that needs to be done here. And if people, if the probability, and this, like you say, I think probably this audience is a bit more sophisticated than most. But as you and I know, risk is mixed of probability and consequence. Although the probability is pretty low, you don't need many people that are struck by lightning per se, but it can happen, right? And the consequence is very, very high. So if your building gets struck by lightning, it could be completely disastrous. And so it's that risk assessment, it's that balance, isn't it, between the probability and consequence. And even though it's a relatively low probability, it can still be a high enough risk to warrant doing something because of the consequences so high, right?
Correct. Yeah.
Cool. Let me just check if we've got any questions. No, we've got a shy audience. We usually have lots of questions. So remember, you've got Lewis for a few more minutes. This has been the main part of the session for half an hour. We'll stay on for about another quarter of an hour, answering a few quick fire. I was going to say lightning questions. I did warn you. A few lightning questions, and we'll look at the surge protection. But if you need to get back to whatever you're doing, thank you so much for joining us. And do check out the website, which just to show you that. I mentioned the previous videos. Do check out all of the videos from all the webinars we've done previously. Robinsons fs.com/video. And if you need to get in contact about any of the issues that Lewis has raised, you can see that on the ticker below. I'll leave that going for a little bit. But Lewis, why don't we go back and look at these the surge protection now? So what are we looking at here?
Yeah, so you've got installation of type 1 surge protection. These ones are installed at points of entry. So for this instance, it's on a main distribution board. These devices deal with lightning current. So if you have a lightning protection system, under BSEN 62305, you must install surge protection at all points of entry. So all cable points of entry into the building needs to be protected. If it's not a system that's been installed to BSEN 62305, we then revert to 7671, of which then it states if you make any modifications to any of the electrical systems in the building, you are to undertake a surge protection risk assessment to determine whether you need surge protection or not. Strangely enough, 7671 basically then says if you have lightning protection, you need to install surge protection, and you don't need to do a risk assessment.
Right. So because that is such a big, like if you've got lightning protection, you decided it was worth protecting yourself from that. So that is like the number one massive cause of surges, or not so much probability, but like it's the biggest type of surge you could possibly get, right? So I see.
Yeah, there's so for instance, a switching surge, it's got very little energy underneath what we call the curve. So it's an 820 wave shape, which means 8 microseconds to get up to 90% of its peak value. and then it goes 20% to get back down to 20 microseconds to get back down to 50% of its value. So the energy underneath that curve is quite small.
Right.
Then you've got lightning energy, which is then 10 over 350. So you have 10 microseconds to get to 90% of its value, and then 350 microseconds to get back down to 50% of its value.
So that's quite a long time by comparison.
So you've also, on these photos, you also have to be careful as well. Different manufacturers design surge protection in different ways. Not all surge protection is correct for the installation. So, for instance, the one on the left actually doesn't meet the criteria of 7671, where it states that it needs to be 12.5 kA per pole. Its max per pole rating is about 6 kV. Some of the earlier models are 4 kV. So you have to be careful of which one you install, and you have to make sure that it conforms to the correct standard.
Right. So having little whizzy LEDs isn't going to cut it. You've still got to have the right one, right? So it might look nice, but it doesn't. You've got to ask the expert as to which one do I need and make sure it's been installed right. So
and it should actually form part of your handover document. So if somebody installs a brand new system, you should have data sheets and a surge protection design incorporated into that.
Right. Okay, we've got a question from Alex here. Alex asks, does surge protection need testing, for example, annually or 11 monthly, or is it part of the EICR?
No, this is something that's been brought up quite a lot. Surge protection itself does not need to be electrically tested at all. As you can see on the picture on the left-hand side, surge protection must have, under 7671, a visual indication. So you can see quite clearly on the one on the left-hand side, which is why we've used that picture, although it doesn't conform in regards to 7671, it clearly indicates that L1, L2, and L3 and neutral are all working fine because they've got green lights. It doesn't need any fancy machines or anything like that to test it. It should form a standard part of the lightning protection test. So lightning protection should, in theory, the way that I've done it, is you go into the main distribution or into the plant room, you check the main distribution board for surge protection, you check the main earth bar for connection between the electrical system and the lightning protection system, and then you note that down on your paperwork. It doesn't need to be tested by an electrician. It literally forms part of the lightning protection testing procedure.
So what about the situation that, and it didn't sound very common, but are there situations where you just have surge protection and therefore you don't have the 11 monthly, 12 monthly lightning protection testing? Does that need testing?
It does need to be checked, but that can form part of the electrical package when you do the EICR. Right. And again, it's literally just a case of looking at the device. But when you do the EICR, you must make sure that the surge protection device can be safely disconnected, because otherwise, when you do your test, you'll find a fault that doesn't exist.
Ah, okay.
Yeah.
Right. Oh, that's worth noting as well. So it doesn't need to be tested, even, but it should just form part of the EICR tests anyway. So one or the other, it'll be picked up, but and it should visually tell you whether it's working, give you that visual feedback. So it's not something that actually needs to be tested, but it does need to be noted as to, if no one's looking at those LEDs one year to another, you don't know, right? So somebody's got to go and actually check that it is working.
Yeah. So some have the LEDs, some have thermal tabs, which is basically a blob of solder. When the device gets struck and it's out of use, it will heat the solder up and then it will flick over between green and red.
Right. Almost like an old sort of fuse type thing.
Yes.
Right. Okay. Brilliant. Thank you. Any other questions, guys? Do keep posting them. And we've got a little video now. Let me see if I can get this working. No promises here, because it was like I said, it was a little bit last minute rejigging things around. But I will see if we can play that. Let's see if we can do that.
So this one will be your standard switching surge, which very low energy. It's very low energy underneath the curve. No real damage, no physical, no visual damage. This one is basically the lightning energy down the same cable, same Ka value, but because of the energy, it causes more of a destructive.
Okay, this is that drop off that you were saying. So we'll see that in slow motion. Lightning.
So there you go. You see, and it's all to do with not the Ka value, but the energy underneath the curve.
Yeah. So it's that. Yeah, it's the sort of, it's there, and it's for a while. And I think, and even to the untrained eye, I remember somebody pointing out that you can see lightning travel down. It's not some. I think I'm right in saying that you can sort of see it go top to bottom. It's not actually instantaneous. The human eye can spot it going down which is kind of interesting as well, right? So which kind of underlines what you're saying, that it's probably more that it's happening over the. Yeah, I can't describe it anybody, but is that true, or is that a different effect?
No, that's true. Obviously, it straights across the sky first to find the build-up of ions, and then it determines within our standard. We use something called the rolling sphere, which is then the last point of where it reaches, and then you have the positive ions and the negative ions then meet. So you'll see that element, and then that's the quick bit, is the connection between the two from the ground to the sky.
Okay, interesting. Yeah. So it'd be something you think would be instant. I mean, it's almost instantaneous, but you can actually track it. So fascinating. So
there are some guys in Florida that they'll see the nimbus cloud come across, and they attach different metal wires to bottle rockets, and they'll send them up. And they've been known to do this. So there's a couple of videos on YouTube, I think it is. And obviously, if you use copper, they get a green bolt that shoots down to ground. So yeah, there's a couple of interesting little videos. I wouldn't have done it personally. I would have, yeah. But they have done it.
You get a lot of lightning, right? It's I guess Benjamin sort of reminds me of Benjamin Franklin with his kite, right? You're researching this in the first place. So, Lewis, we've got a few quick fire questions. I'm not going to have time to do most of those, but just a couple of those. So, one, is lightning protection a legal requirement? I know we said this, but just a reminder for the audience.
Yeah, so it's not a legal requirement. However, it's governed under the Health and Safety Working Act. However, if you have a desir or coma site, it's then a mandatory requirement under desir regulations and standards.
Desir explosive, right?
Yeah.
Cool. And how do I know if my building needs lightning protection?
Formal risk assessment done by a specialist, also somebody that's qualified to undertake those, which you ask for their Atlas accreditation, the design accreditation.
Okay, great. And you said how often should be tested?
12 months, no more than 12 months if it's deemed as critical. So basically, if it's occupied, however, 11 months so that you get a change in season.
Brilliant. And what sort of documentation do I need to keep to maintain that compliance?
So you should have an O&M operation manual. You should have a test certificate, a calibration certificate for the test meter that's been used, and an as-built drawing for the lightning protection, and if possible, the surge protection element as well.
Brilliant. So make sure we've got all of those. And just to finish off then, so how can, we talked about this a little bit, just to be really explicit, how can a specialist help with ensuring that compliance?
So you would potentially get them to come out, check your system over for testing, but they can also undertake a site survey. They can then verify the design, and they can also then undertake a risk assessment to ensure that the system has been installed to the correct level of protection. Sorry.
And presumably then doing that annual testing and maintenance or all of that stuff as well.
Yes.
Brilliant. Look, Lewis, I know this isn't your favorite thing, so I really appreciate you coming on board and giving us your expertise. Otherwise, it would have been just 45 minutes of lightning puns, which would have, I don't think that would have helped anybody. So I really appreciate that. So I will let you go and we'll catch up later on. Thank you so much. So guys, thank you again for watching. Do check out our videos, as I said. There's plenty of those now, and then we've got a whole load of other videos on a range of subjects, as well as the webinar videos. And also do get in contact if any of the issues raised today have been relevant for you, but just really, really appreciate your time joining today. We know you're busy, and I hope you enjoyed your lunch learning all about lightning. So thank you so much. Cheers, and we'll see you next time.